Okay, in this video we'll be looking at the cosine rule without proof, so we'll just get a feel for how it works, how to think about it, and what it does. So we'll start with a familiar right-angled triangle with side lengths A, B, and C. And so because it's right-angled, we have Pythagoras saying that c square equals a square plus b square. The big square equals the sum of the little squares. Now we're going to leave a and b the same length, but if we change the angle they make, so it's not right-angled anymore, then of course Pythagoras breaks and we see that with this smaller acute angle we've made there, the side C that used to be the hypotenuse has shortened. What we call the cosine rule is how we can fix this sort of broken Pythagoras equation to work when we don't have a neat right angle there. So remember, it's this angle's fault that C has shortened, and once again we see this interaction between an angle and its opposite side in a triangle. So as is convention, we label this opposite angle big C. And it turns out that if we chug through some calculations inside the triangle, this shortening of side C is just equivalent to subtracting 2ab cos C in the usual Pythagoras formula. So this thing here on the right is called the cosine rule, and just like in Pythagoras, if the other two sides A and B get swapped, we can sort of verify inside the equation that nothing really changes. It's still just a square plus b square minus 2ab cos C, but written in a different order. So it means that a and b are interchangeable. You can swap them without consequence, and you don't really have to care which one you call A and which one you call B. But what is important to always check, though, is that this angle between these two sides, this angle C here, is opposite the little c in the equation. So just like how with Pythagoras, the hypotenuse being opposite the right angle made it the special side, so too now the side opposite the angle we're looking at is the special side, the one that sits all by itself on one side of the equation. And so just like usual again, make sure little c and big C are opposite each other. One more thing though, we can write this with the angle C by itself on one side of the equation. Now I won't work through all the details here, but it would involve subtracting the little c square across to the other side, then dividing through by the 2ab that was stuck to the cos C. But this form is also given to you in your reference sheet, and it's clearly the more useful form for working out angles, as we'll see in a moment. So first, let's see how to work out a side length using this cosine rule. We have a situation where we're looking at three sides and one angle in this triangle here, and we're trying to work out the length of x. We're going to use the form that puts the side length, little c, on one side of the equation. Now remember, little c must be opposite big C. So we're relieved when we see that the x we're looking for is indeed opposite the 54-degree angle we've been given. And so that means we can put x squared by itself on one side of the equation. Then remember, we don't really need to be as careful with who a and b are. They're just the other two sides. Okay, so let's just put a equals 4 and b equals 3. But again, really, it doesn't matter. Okay, and so we can just put in all the numbers now, and put that whole right-hand side into a calculator, giving 10.89 something something something. And so to work out just the x itself, we can undo the square by square rooting, okay, and we get 3.3. Okay, so we'll finish by working out an unknown angle. So because we're trying to get an angle, we'll use the form that puts the angle by itself on one side of the equation. And that angle is of course going to be the theta we're looking for. And so on the triangle, we check to see which side is opposite this theta. That's always the side to look out for. And we find it's this 5 here. So that means the little c square in the equation is going to be 5 square. Okay, and so we're going to have a minus 5 square upstairs in the equation. Then again, the A and the B are just the other two sides in whatever order we like. So we might use A equals 4, B equals 6. And so upstairs in the fraction, we have 4 square plus 6 square. Downstairs, we have 2 times 4 times 6. That works out to be 0.5625. And so to get theta by itself, we can do the backwards cosine of that number. And that gives us something like 55 degrees and 46 minutes or something. Okay, so that's the cosine rule. It's just a version of Pythagoras that works for non-right-angled triangles. And so just like with Pythagoras, you just need to keep an eye on the side opposite the angle you're looking at. This will always be the special side in whichever form of equation you use, and for the other two sides, just plug them into the pattern and off you go. Okay, so that's all for this one. Thanks for watching. See you next time.